So good morning all. Today I'm going to share with you uh, the different bonding agents, how they have evolved over time. Yes. So the reference book is actually Phillips Science of Dental Materials and Textbook of Dental Materials by Craig. So let us get into the topic of bonding agents. So before knowing about bonding agents, we must know what adhesion is. Okay. So adhesion as such is nothing but a state in which two surfaces are held together by interfacial forces like valence forces or interlocking forces or both. And for a proper adhesion to take place between two surfaces, we need to know certain terms: adhesive, adherent, and adhesive strength. So what is an adhesive? Adhesive is the material which is usually a viscous fluid that joins two substrates together by solidifying, resisting separation and transferring a load from one surface to the other. Adherent is the surface to which this adhesive is added, and adhesive strength is the load-bearing capacity of the adhesive joint. Okay, and how can this adhesion take place? So either it can be by means of mechanical adhesion, or by adsorption adhesion, or diffusion adhesion, or it can be a combination of all these three. Now, why do we need to know about this adhesion? Why do we need to know about this bonding agent in dentistry? Why? Because it's indicated in various treatments. Like you want to restore a cavity, you want to change the shape and contour of the anterior teeth, you want to seal the pits and fissures, you want to bond the brackets, you want to desensitize the exposed root surface. Okay. Yes. So you want to desensitize a root surface, or you want to bond an amalgam restoration, or you want to bond the fractured segments, or you want to bond the prefabricated fiber or metal pores or cast pores, or you want to seal the root canals during endodontic therapy. Everywhere a bonding agent is necessary. Yes. So this bonding initially, now you can separate them into enamel adhesion and dentin adhesion. So we'll see about each in detail. So it was initially in 1955 that Buonocore, he described a clinical technique where a diluted phosphoric acid was used to etch enamel. Okay, and this resin would mechanically lock to the roughened enamel surface, which was created by means of phosphoric acid. Okay, and so initially the first clinical use of this technique where phosphoric acid was used was in the pit and fissure sealants. Okay, so there was formation of resin micro tags within the enamel surface, into which the cement retained itself. Okay, and the bonding was done. Okay, so how long do you etch? So currently the etching time of the etchant is 15 seconds. Okay, so initially it was 60 seconds, but now we know that 15 seconds is more than enough to create a roughened surface in the enamel. Okay, and what is the concentration we use? It is 37% phosphoric acid. You can't go more than that, you can't go lesser than that, because greater than 40% phosphoric acid, calcium salts, they don't dissolve. Okay, so the etch patterns so obtained are usually very poor. Or what if it is less than 37%? So if it's going less than the desired concentration, what happens is you have formation of dicalcium phosphate dihydrate. Okay, and this formation of dicalcium phosphate dihydrate layer, it cannot be rinsed off easily. So you can't change the concentrations. It has to be ideally around 37% of phosphoric acid. And not just phosphoric acid, but you, instead of phosphoric acid, you can also go for EDTA, citric acid, malic acid, polyacrylic acid, and tannic acids. And not just acids, but you can also go for alternate systems, like you have lasers, and then you have air abrasion using aluminum oxide particles. But however, these are not that efficient when compared to up phosphoric acid etchants. Yes, it's considered inferior lasers, because if you see, the shear strength of composite to phosphoric acid etch enamel is nearly around 20 MPa, and ideally we need at least 17 to 21 MPa of bond strength to prevent the disruption of bond which is occurring between the composite and the tooth. So which is easily got through etching using phosphoric acid. Then when we see about dentin adhesion, well, bonding to dentin is not that easy as compared to enamel. Why? Because of the structure of dentin. Okay, structure of dentin, which is very much different when compared to that of the enamel. The formation of a smear layer which is there, and the various stresses which are there at the resin dentin interface because of the exposure of the dentinal tubules. So all this makes dentin adhesion a little complicated when compared to your enamel adhesion. Yes. So why? So when we'll see about each. Like if you take the structure of dentin, how is it different from that of enamel? Enamel has 90% hydroxyapatite crystals, but whereas when you see dentin, it has only 50% of hydroxyapatite crystals. So the rest is constituted by water and collagen. Okay, and this dentinal tubules keep exerting pressure, thus creating a decreased stability of bond between the resin and dentin. Okay, and also the number of dentinal tubules is not the same throughout. It decreases from pulp towards the DEJ. Okay, also also the dentin thickness, because if you want an adhesion to take place, how much amount of thickness of dentin remains is very important. Okay, and so bond strength is greater for superficial dentin and is less for deeper dentin, because when you go to the superficial dentin, the thickness is much higher when compared to the deeper dentin. So naturally the bond strength is also higher. Next, when you take a smear layer is nothing but a residual organic and inorganic components which form on the tooth surface once you prepare the tooth surface. And this is composed of collagen, inorganic tooth material, saliva, blood, bacteria, and coagulated proteins from collagen denatured by frictional heat. Okay, so all these together form the smear layer. Okay, so for an optimal bonding to occur, the smear layer has to be removed by etching and rinsing. Okay, or you have to use self-etch adhesives where though you do not completely remove the smear layer, you at least modify the smear layer so that the bonding occurs through the smear layer. Okay, but however, recently they have found that complete removal of smear layer usually increases the dentin permeability by around 86%. So it's always preferable. So here you can see this is a structure where you can see the dentinal tubules, and then you have a smear layer forming on the surface of the dentinal tubules with a layer of it extending into the dentinal tubules forming a smear plug. So this has to be removed or modified or altered for the bonding agent to penetrate into the dentin. Yes. Now, there is also stress which is occurring at the resin dentin interface. Why? Because when you have composite around the dentin, shrinkage occurs, and because of this shrinkage, you have stress which is occurring. To minimize this, and this stress again can become a reason for incomplete bonding of the bonding agent to the tooth surface. Yes. So basically, when we talk about dentin bonding agents, okay, they are no longer relevant now, because initially, though these two concepts were into use, like you have enamel bonding, you have dentin bonding, and you have to see to that in dentin it is both hydrophilic and hydrophobic, because dentin has water content also. So all these were taken into consideration, but now we don't have the demarcation. It's just bonding agent. So if it is bonding to dentin, we are happy that it is bonding to enamel also. Okay, so because when you talk about dentin bonding agent, it has to be hydrophilic to attach to the water content which is present in the dentin. It has to be hydrophobic to attach itself to the composite which is added to the tooth surface. Okay, and then conditioning of dentin also has to be done with acids. Okay, and then the smear layer has to be removed. So all this has to be taken care of when we are considering about dentin bonding agents. So here you can see in this figure, this is a figure where a conditioning is being done for the dentin. So you can see that these are the dentinal tubules, and you have this dentin which is getting etched. So this is the etched dentin, and then you can see the dentinal tubules there, and inside the tubules you can see the collagen fibrils which are getting exposed. Yes, so when you talk about dentin, it has to occur in stages. You have to first create microporosities, and then you have to condition the dentin, and only then a bonding will occur. Okay, so all has to be taken care of. And how long you can etch? Similar to enamel etching, again, this is ideal duration is 15 to 20 seconds. You can't go for more duration. If you etch for more than 20 seconds, what happens is that the collagen will undergo collapse because of denaturation, and decreased monomer infiltration will take place. Because when the collagen collapses, naturally the monomer cannot infiltrate inside the dentin. Okay, and you can't do it for less duration also, because there won't be any depth of etching which has stayed in place. So an ideal of 15 to 20 seconds of etching has to be maintained in the dentin. So followed by etching, what you have to do is you have to do a priming or conditioning. Okay, so what you do is you are going to apply a primer to the already etched or conditioned dentin. Why? To improve the diffusion of the resin into this moist demineralized dentin. So already you have demineralized the dentin, you have etched the dentin. Now you're going to prime the dentin so that it's easier for the adhesive resin to penetrate. Okay, and now this primer is a combination of hydrophilic and hydrophobic components. So what are the main priming agents we are using here? It's hydroxyethyl methacrylate 4-meta. Okay, so this both are mainly used as the priming agents. So the priming agents are hydroxyethyl methacrylate or HEMA, and 4-meta or 4-methacryloxyethyl trimethyl anhydride. Yes, so what is the mechanism of dentin bonding? Okay, so here you can see that there is a smear layer. So what we are going to do is we are going to do acid washing or rinsing, and this is going to remove the smear layer. It's going to dissolve the hydroxyapatite crystals. Okay, but after you etch, you can see that there is drying and shrinking of the collagen molecules. So you have to rehydrate this collagen molecules and bring back the collagen to its original state by means of priming. Okay, and so that it's easy for the monomer to penetrate inside this dentin. Okay, and there's better adhesion. Yes, so how has this dentin bonding agents evolved? So this dentin bonding agent, it has evolved from 1960s, and it is evolving. So initially it was a non-bonded composite. There was no anything called bonding, and then it was in 1970 that because of few people like Binocor and others, we had this acid etching into place, which was primarily an enamel bonding agent. Then it was only in 1980 that Kuseyama and Nakabayashi, they all introduced the dentin bonding composites, and this evolved into various generations. You had first generation, you had second generation, and in first generation and second generation, there was no any 3 steps. You didn't have any etching or priming or bonding. There was no any demarcation. But whereas when you came to the third generation and the fourth generation, it involved 3 steps. There was an etching, there was a priming, and then there was a bonding. And it kept evolving. And now at present, we are now in a 7th and 8th generation bonding systems. So we'll see about each system in detail. Okay, so based on how you treat the smear layer, you can either remove the smear layer, you can modify the smear layer, or you can partially dissolve the smear layer. So you have bonding agents doing any of these things to the smear layer. Okay, and most of the components what we have now, most of the bonding agents what we have now consists of a conditioner, primer, and an adhesive. Yes, so what is a conditioner? So conditioner is nothing but an etchant. It's a weak organic acid or a malic acid, and you can also go for a phosphoric acid or a nitric acid, or it can even be a chelating agent like EDTA. Yes, so the main action of this conditioner or an etchant is that it removes the smear layer, demineralizes the peritubular and intertubular dentin, exposes the collagen fibrils, demineralizes up to a depth of 7.5 microns. Okay, and if you see, the peritubular dentin is etched more when compared to the intertubular dentin, and thereby the dentin permeability is increased. So basically, it removes the smear layer, demineralizes the dentin. Yes, next comes the primer. Okay, so this primers, I told you already, we are using HEMA, we are using 4-meta. Apart from that, we also have NMSA or N-methacrylol, 5-amino salicylic acid, and then we have N-phenyl glycine, and then pyromaleic diethyl methacrylate. So these are some of the examples of the primers what we are using. So these primers, what they do is they link the hydrophilic dentin to the hydrophobic adhesive resin. Yes, so once you have etched, you're going to apply a primer, and this primer is going to bond the dentin to the adhesive resin, and it's going to promote infiltration of demineralized peritubular and intertubular dentin, and also it increases the wettability of the dentin surface. Initially it was dry after etching, so that is changed, and the surface energy and wettability, everything is increased by means of this primer. Followed by that, we are going to apply a bonding agent. So you have etched, you have primed, and now we are going to add the bonding agent. This bonding agent is nothing but an unfilled or a partially filled resin, which will contain some components of the primer, and they help in increasing the bond further. Okay, so the adhesive or the bonding agent combines with the primer and forms resin tags to seal the dentinal tubules. Yes. Now, let us see how these dentin bonding agents have evolved through the generations. So initially, in the first generation, it was a surface active comonomer, namely N-phenylglycine glycidyl methacrylate. The main action was that it chelated with calcium on the tooth surface and created a chemical bond of the resin to the calcium. Okay, but however, this bond strength was very less. It was only about 2 to 3 MPa. Okay, so then came the second generation bonding agent, whose bond strength was 3 times higher when compared to the first generation. Again, here, instead of the co-monomer NPG-GMA, okay, we used phosphorus esters. Okay, phosphorus esters of methacrylate derivatives were used. Okay, and the mechanism of action is that adhesion was by means of ionic interaction between the negatively charged phosphate groups and positively charged calcium in the smear layer. So adhesion was little better in the second generation. But again, here also there was no any demarcation between HN primer or bonding agent. It's just phosphorus esters of methacrylate which were used. Okay, so the main disadvantage was that though the bond strength was high when compared to that of the first generation, it was still lower, say around only 5 to 6. But what we need is around 20 MPa. Okay, so then it kept evolving, and then you had third generation dentin bonding agents in which we used HEMA and then 10 MDP or 10 methacryloxydecyl dihydrogen phosphate. So all these were introduced. Okay, and the main mechanism of action was that they did not remove the smear layer. Okay, so first and second generation they removed the smear layer, but whereas in the third generation it did not remove the smear layer. It only modified it and made the penetration of the monomers much more easier. Yes, so currently we are into our fourth generation of adhesives. Okay, so currently what we do is we etch and rinse, because in third generation the smear layer was only modified and not removed. But currently what we are doing, currently we are into the fourth, right from fourth until 7 and 8 we have been using. So currently what we are doing is we are removing the smear layer. Okay, because smear layer is thought to inhibit complete penetration of the composite into the tooth surface, and thereby we are doing a total etch technique. Okay, so total etch means it etches both enamel and dentin at the same time. Okay, so the main mechanism of action is that there is complete or partial removal of the smear layer, and then there is demineralization of the dentin. Also, intertubular and peritubular dentin are demineralized. Okay, and there is increase in the surface energy of dentin once it's been primed, and then there is formation of resin tag and hybrid layer. So all this occurs when you do total etching. Okay, and here another question is when we are telling etch and rinse. Okay, and once you do the etching and once you rinse and then once you apply the primer and then when you're applying a bonding agent, now you should know how dry the dentin has to be. Should it be too dry or should it be too wet, or how it should be? Okay, so the answer is that it should be hydrated and it should be clinically glistening and moist, but not too wet. Okay, so you have to just blot the excess water, dry it with a sponge, and just touch it to the surface of the tooth so that just the water is removed. You cannot blow, you cannot use a suction. Okay, you can't make it too dry. Okay, so why you cannot make it too dry? Because when it goes too dry, then you're going to end up collapsing the dentinal tubules. So there's going to be shrinkage in the dentinal tubules, and so the resin tags cannot form inside such as dentinal tubules. And it cannot be too moist also, because when it is too moist, it dilutes the primer, and phase separation occurs between the hydrophobic and the hydrophilic components of the bonding agent. Okay, and that can lead to post-operative sensitivity. So it cannot be too moist because it will result in sensitivity. It cannot be too dry because the collagen will undergo collapse, and it will lead to shrinkage of the collagen tubules. So naturally bonding will not be effective. Yes, resin tags will not be able to form. Okay, so now, as we have seen the basics as to how it is occurring, how the bonding agents have been working, now we will see the fourth generation. So we already saw the third generation wherein the smear layer was not removed but modified, and then came the fourth generation, which is again an etch and rinse technique, but here we are going to remove the smear layer, and here we are going to use an etch and primer and a bonding agent. Okay, so phosphoric acid is the agent, and then you have a primer which is going to have a hydrophilic monomer as well as a hydrophobic part. Okay, so example of the primer here is HEMA, NPG-GMA, and Penta. Okay, and then you're going to go for bonding agent. So the bonding agent is unfilled or filled resin, which can be BIS-GMA, UDMA, along with TEC-DMA and HEMA. So these are the most common bonding agents we're using. So I repeat, the bonding agents we use is unfilled or filled resin, which may be either BIS-GMA, UDMA, along with TEC-DMA and HEMA. So thus, once you have etched and then you have rinsed and then you have primed, and then you're going to apply the bonding agent to the etched surface. Okay, and this is going to help in formation of a hybrid layer. So this was given by Nakabayashi in 1982. So the main advantage is that the bond strength is very good. The disadvantage is that naturally it is technique sensitive and it is time consuming, and you might end up over wetting or over drying the dentin. So you have to be very precise in your procedures. Okay, so these are the various brands which are available under fourth generation. And so if you see the steps, you have etchant. Okay, you apply the etchant and then you rinse and then you dry and then you apply bottle 1, which is primer, and then you apply bottle 2, which is the bonding agent. Okay, and then you cure. So this is fourth generation. So in fourth generation, you're going to have an etchant, and then you're going to have bottle 1 primer, bottle 2 adhesive. So 3 bottle system it is. Fourth generation. And what is a hybrid layer? So it's a process, it's a molecular interface between the dentin and the composite resin. Hybrid layer is mainly formed by this bonding agent between the resin and the dentin. Okay, and this bonding agent, this hybrid layer, sorry, it's going to have 3 layers. You're going to have a top layer, which is composed mainly of the loosely arranged collagen fibrils, and then you have the middle layer where you have collagen fibrils being replaced by the resin because of the hybridization, and then you have base, and this base contains partially demineralized dentin alone. Yes, so superficial layer has loosely arranged collagen fibers, middle layer has this resin tags formed by means of the resin, and in the base you have partially demineralized dentin. So this is how it is. So you can see the image here. So these are the dentinal tubules, and this is the adhesive resin which has formed the hybrid layer. Okay, so this is a hybrid layer which is forming, and within the dentinal tubules, so you have the dentinal tubules, and then you have peritubular dentin, and then you have the intertubular dentin. Okay, and here you can see that resin tags are forming. There's a hybrid layer which is occurring between the bonding agent and the dentin. So between the bonding agent and the dentin, you have the hybrid layer. This hybrid layer is going to have a topmost layer which is going to consist of collagen, and then you have a middle layer where you have the resin which is replacing the collagen, and then here in the deepest layer or the base, you're going to have demineralized dentin. Okay, so this is the hybrid layer present beneath the adhesive. Okay, so then came the fifth generation, which is just a two-step procedure where you just etch and rinse, and then you don't have two bottles. you don't have bottle 1 and bottle 2 and then an etchant, but instead it's etchant separate, and then you have primer and adhesive coming together. Okay, so it's just etchant and then one bottle which is going to contain primer together with the adhesive. So you're going to apply etchant, rinse the etchant, apply the primer and adhesive which is there together as one single bottle, and then you're going to cure. So this is your 5th generation what we are using, okay, at present. So then came the 6th and 7th generation where they introduced self-etch adhesives. Okay, so these self-etch adhesives, what they do is they dissolve the smear layer and create porosities in the substrate without needing an extra conditioning agent, which is to be applied in a single step. So there is no step called etching, rinsing. That etch and rinse step has been minimized, and you have everything together. Okay, so it's less technique sensitive, so the number of steps naturally it's decreased. Okay, so it just simplifies the entire procedure as such. So this self-etch adhesives, if you see, you either get it as a 2-component self-etch adhesive where you have 2 components applied as 2 steps, or 2 components, mix it together and apply it as 1 step. Or you can go for the 7th generation, which is just 1 component self-etch adhesive. So everything is made simple in the 7th generation. So I repeat, okay, you have 4th generation, okay, in which you have a 2-bottle system, you have an etchant, and then you have bottle 1 and bottle 2, and then you have a 5th generation where etchant is separate and primer and adhesive come together as 1 bottle, and then you have the 6th generation where the 7th generation where etchant work itself is not there. You just have 2 components which you apply it as 2 steps, or you mix both the components and apply it as 1 single step, which is a 6th generation. And in the 7th generation, it's just 1 component. Okay, so if you see in the 6th generation, you have 2 components. So you have etching and priming of enamel and incorporating smear plugs into the resin tags. Okay, so you just have 2 components in the 6th generation, etchant and primer together as 1 bottle. You leave it for 10 seconds and then apply the bottle 2 and then light cure. There's no work of rinsing at all. There's no work of etching and rinsing. You just have to apply bottle 1, which is etchant plus primer, wait for 10 seconds, apply bottle 2. Okay, or you have bottle 1 and bottle 2, which you have to combine it together, mix it together prior to application, then apply it directly on the tooth. Okay, so the main advantage is that it is less technique sensitive, less time consuming, but the main disadvantage is that shelf life of such materials is very short, so it's going to become much more costly for us, and it's incompatible with chemical cure composites. So that is one of the major disadvantages with the 6th generation composites, where you cannot use it with chemical cure composites. So then came 2-bottle 1-step system, which is again a type 2, where you have bottle A containing primer, bottle B containing phosphoric acid modified resin. So both you mix it together and then you apply. So then in the 7th generation, if you see, okay, etchant, primer, adhesive, everything is just 1 bottle. You don't have bottle 1 or bottle 2, which you have to apply first, wait for 10 seconds, apply bottle 2, or mix both, apply it together. So all that is not there, which was there in the 6th generation. Everything is together, 1 bottle, you just apply and leave. Fine. Okay, so that you call it as eye bond. Okay, you just apply 3 consecutive coats. Gentle air pressure is given to dissolve the excess solvent, cure it, and then place the composite. Okay, so the main advantage is that it is most efficient application procedure. It's a unit dose procedure, so less time consuming, less technique sensitive. Disadvantage as such, similar to 6th generation, you have a reduced shelf life and then you have less sealing capacity, and bond strength again is very less when compared to the traditional etching what we do with the ceramics, and incompatible again with the chemical composites like your 6th generation bonding agents. Okay, so then comes the 8th generation bonding agents like the Futura Bond DC. It's the 8th generation bonding agent, and the main advantage of this 8th generation bonding agent over 6th and 7th bonding agent is that it is dual cure, and you can use it along with light cure, self cure, or dual cure resins. Okay, so and it does not need 3 coats; just 1 coat is enough. So all the disadvantages are overcome with this 8th generation Futura Bond DC, where you apply it as 1 single coat and 1 single material, and you can use it for anything. either for light cure essence, self cure essence, dual cure essence, for anything you can use. Yes, and bond strength is also very high. See, you're getting around 30 MPa for dentin and 31.2 MPa for enamel. Yes, so recently you also have universal adhesives which you can use for total edge, self edge, selective edge. You can use it for light cure, self cure, or dual cure materials. You can use it for direct or indirect substrate. You can also use it for dentin, enamel, metal, ceramic, porcelain, zirconia. For bonding of anything, you can use this universal adhesive. So you call it as an all bond universal. Yes. So now when you see the failures of these bonding, this can occur at various levels. Okay, so between the mineralized and demineralized dentin, or failure can occur between demineralized dentin and the bonding agent, or within the layers of bonding agent there can be a failure of bonding, or between the bonding agent and the composite resin you can have some failure. So why this can occur? Because of the material what we're using, because of how we have been using, technique sensitive, right? And any lesion, how it is, or what substrate is there, whether it is enamel or dentin, how the dentin is, which region it is, whether it is near the pulp, how much dentin thickness remains. So based on all that, the failures can occur. Yes, so in conclusion, dentin bonding agent as such has become a very important part in the field of dentistry, and we must know the various evolutions and various innovations in this bonding agents. So let us see the few questions which have been asked in relation to this bonding agents. The first question is, true about self-etch primer is. So self-etch, I told you, self-etch comes under which generation? It comes under 6th and 7th generation. So the main advantage of self-etch primer is that it does not remove the smear layer, but it only binds it to the dentin. So that's the answer. And then a dentin primer. Okay, so the main function of primer is that it increases the surface energy and wets the dentin surface. Okay, so that's the answer, because the main function of primer, I told you, is it envelopes the external surface of collagen, and then it remineralizes the collagen, and then increases the surface energy. But whereas the acid is just the opposite. It removes the smear layer, exposes intertubular and peritubular dentin, decreases the surface energy, and shrinks the collagen. Yes, so primer is just the vice versa. So answer is B. And when the concentration of etchant is more than 50%, it forms a complex which prevents further dissolution. So what is that complex? It is called monocalcium phosphate monohydrate. Okay, so this monocalcium phosphate monohydrate forms when the concentration is more than 50%. Yes, and a percentage of phosphoric acid where dicalcium phosphate monohydrate is formed that cannot be rinsed off. So the answer is 25%. So answer is option A, 25%, because when it comes to less than 37%, you have this formation of dicalcium phosphate. When it goes to more than 50%, you have monocalcium phosphate forming. So answer is option A. Okay. Then when you come to the fifth question, the components of fourth generation dentin bonding systems are described as total etch multi-water. So answer is option C. Okay. So answer is option C, which is total etch multi-bottle. Okay. Because if you see fourth generation is total etch multi-bottle, you are going to have an etchant, and then you're going to have a bottle 1, and then you're going to have a bottle 2. So answer is option C. Okay, so C is the answer for fourth generation. Total etch multi-bottle. Okay. Next is type 1 enamel etching pattern. So one thing you must know is that enamel etching can occur in two patterns. It can either be dissolution of the prism cores, or it can be dissolution of the prism peripheries. So in type 1, it is usually dissolution of the prism cores. But whereas in type 2, it will be dissolution of the prism peripheries. So answer is option B. Then when you come to the seventh question, after the dentist has completed an etching procedure on a class 3 composite preparation, the preparation gets contaminated with saliva. In response, the dentist should do which of the following? Blow away the saliva with air, then proceed? No. Rinse away the saliva, dry the preparation and proceed? No. Wipe away the saliva with pellet, rinse the preparation with water, dry it with air, proceed, no. Rinse away the saliva with water, dry the preparation with air, then repeat the entire etching procedure. Yes. So answer is option D, because whenever saliva is going to contaminate the already etched enamel and dentin, it should be rinsed with water, it should be dried, and then you have to blot it dry in case if it is a dentin. For enamel, you can just dry it with air. But whereas if dentin, you just have to blot it and then repeat the entire etching procedure. Yes, because the salivary proteins, in case they are present, will decrease the bond strength of composite to enamel and dentin. So you have to etch it again. Yes, so hope you have understood the evolution of the bonding agents, and you'll be able to answer the questions which come in relation to this topic. Yes, so thank you.